Now we're going to take up the one more analysis on the simply supported beam. So with an eccentric loading. So SFD and BMD for a simply supported beam with an eccentric point load. So here we have a beam of a simply supported beam of AB of span length L carrying an eccentric load W at the point C. So what are all the support reactions we are going to get? So the point C is acting at a distance of A from capital A and B from the point B. The support reactions will be, so let RAV will be the support reaction at the point A and reaction at the support B will be RBV. Now taking the moments about the point A, that is RBV into L will be equal to capital W into A. So that is sum of the clockwise moments will be equal to sum of the counterclockwise moments. So that means RBV into L will be equal to capital W into A. So RBV will be equal to W into A by L. So W into A by L will be RBV. So W into A by L will be RBV. So then I need to find out what is the reaction at the support A. The sum of the upward reaction will be equal to sum of the downward reaction. So what is that? RAV plus RBV is acting upwards will be equal to sum of the downward reaction, which will going to be capital W. So therefore, I want RAV. So RAV will be equal to W minus RBV. RBV what I have got is W into A by L. So minus W into A by L. So on LCM and simplification, you will going to get W into 1 minus A by L. So that will be equal to W into L minus A by L. What is L minus A? So L minus this total distance is L minus A will going to give you B. So W into B by L. So RAV will be equal to WB into L. So now we found out the support reactions at both A and B, and now we need to write the shear force diagram and the bending moment diagram. So as there is no horizontal load, so naturally RAH will be equal to 0. So now we go for the shear force and bending moment. So this is the beam what you have. So we need to consider the portion AC now. Once you are considering the portion AC, now consider a section XX at a distance X from A. So SF at this reaction RAV will be equal to WB into L, W into B by L. So that is the reaction 1. So shear force is positive as left portion slides upwards towards the right portion with respect to the right. SF is constant between A and C. So plus W into B by L. Between B and A and C it remains constant as there is no other load. So between A and C now, between A and C, SF will be equal to plus W into B by L. Now what happens? BM at the section XX. So once you are considering the bending moment at the section XX, that is load into distance, as the beam is sags towards the upward direction. So it becomes, by convention, it's positive. So that will be equal to plus W into B by L into X. Call this equation as 2. So the bending moment is positive as the moments of W into B by L taken from the left side of the section XX is clockwise. So because due to that, you are going to have the sagging bending moment. So naturally, you will going to get the positive value by sign convention. Now, when the value of X is equal to 0, what happens? Bending moment at the point A will be equal to 0. BM at A will be equal to 0. Similarly, when X is equal to A, BM at the point C, which will be equal to W into A by L into X. So when X is equal to W into B by L into A, X substitute the value of X as A. So W into AB, W into A into B by L. So as the power of X is equal to 1, so naturally the bending moment follows the equation of a straight line. So now you consider the portion BC now. When you are considering the portion BC, So consider a section XX at a distance x from B. So SF at this section will be equal to minus RBV, because section towards the right side acting upwards is negative. Section towards the left side is positive. The section towards the right side, acting upwards is negative. Section towards the left side acting upwards is positive. So that is the convention what we follow. So from that convention, section towards the right side acting upwards is negative. So naturally the force minus RBV will be equal to minus W into A by L. So call this equation as 3 now. So this is how the shear force is negative as the right portion slides upwards with respect to the left portion. So SF is constant. So as there is no other load between B and C, so naturally it remains constant at all sections between B and C. So between B and C, SF will be equal to minus W into A by L. Now what is the bending moment now at the section XX? Again, you are going to have a positive value. So because the bending moment or the beam sags at that particular point at this section XX, as the load is acting upwards, so naturally the beam will going to try to bend in this direction. So this becomes the sagging bending moment with respect to the point XX. So that will be equal to plus W into A by L into X. So call this equation as 4. As the power of X is 1, so naturally you will going to get it as the linear line, the variation. The bending moment is positive as the moments of W into A by L taken from the right side of the section XX is counterclockwise. Again, it is positive value. So when you are considering the value of X is equal to 0, so what happens? W into A by L into X. So that the bending X, put the value of X is equal to 0, so you are going to get it as 0 bending moment at the point B. When the value of X is equal to B, so what happens? W into A by L into X, put the value of X is equal to B. When the value of X is equal to B, so the bending moment at the point C we will going to get, so BM at C will be equal to plus W into A into B by L. So when you are considering from A also to the point C, which will be W into A into B by L, and from B also towards the point C, again it will be equal to W into A into B by L. So equation 4 shows this is the equation number 4. That equation shows that since the power of X is positive, only power of X is 1, therefore it follows the equation of a straight line. So when you are plotting with respect to the shear force and the bending moment, so if you have SFD, so shear force at the point A will be equal to plus W into B by L, and between A and C it remains constant to W into B by L. So at the point C it will going to drops to minus W into A by L, and then it remains constant between W into A by L, and then it becomes 0 here. So as the bending moment, as the shear force changes its sign at the point C from positive to the negative, hence the bending moment will be maximum at that particular point, which will be equal to W into A into B by L. So maximum bending moment at the point C will be equal to W into A into B by L. So this is how you will be able to plot this when the bending moment at the point A is 0 and the bending moment at the point B is also 0, and the bending moment at the point C will be equal to W into A into B by L. As the power of X is 1, so therefore you are joining between A to C as a linear line and also from B to C as the linear line, as the equation of a straight line. So this is how you will be able to analyze the bending moment, the simply supported beam with an eccentric point load, and how we can able to get the support reactions and also the shear force diagram and also the bending moment diagram. Thank you.